Good morning to my both panels, which is Sir Hazli Roslan and Madam Dalila Misman. So my name is Dinesh Analakimurthy from BNE. My metric number will be CN180064. So today I'll be presenting my FYP, which is given, which my FYP's title is Thermal Energy Harvesting for Self-Powered Smart Home Appliances. So for today, there will be two things. There will be five things which I will be explaining today. First is chapter 1, my introduction. Second will be my literature review. Third will be my methodology. Fourth will be my results. And fifth will be my conclusion. Okay. For my chapter 1 introduction consists of 4 items, which is project background, problem statement, objectives, and also project scope. Okay. For my project background, what I've stated there is usage of air conditioner. So, okay, since in this our country nowadays, the climate is very hot. Malaysians can't stand it. So, usage of air conditioner in each and every household is increasing rapidly. So, since it's increasing rapidly, no one have the concern of even thinking about wasting of energy. So, energies are being wasted from the air conditioner's condenser. Okay, there are many energies which is being wasted. So for my FYP, I'll be choosing heat energy to be recycled. Okay, energy has to be recycled. There are benefits of recycling energy. I'll explain it today to both of my panels later. So TEG is being mounted for my project, where TEG is thermal electric generator, where it will convert from heat energy into electrical energy, usable electric. Okay, next will be my problem statement. Okay, for my problem statement, energy is being wasted, what I have said just now. So we have to recycle the energy. We can use it. Okay, next is minimum of 13 watts is required to charge the 12-volt battery. Okay, why do I say so? Is for my whole system, it starts from TEG. Okay, TEG is being placed in my discharge pipe inside my condenser. Okay, from that, TEG produces output current, which is DC. Okay, from that DC, it will be transferred to battery. Okay, why is there a need of battery? The need of battery is to be as a source backup. Okay, if example a house who didn't even on their air conditioner for almost 2 days. Okay, my battery helps them to even use it. My battery helps them to store the energy, which can be used later on for up to 3 days. Okay, for up to 3 days, my energy, the energy which is being converted to usable electric, can be stored up to 3 days. Okay, so next will be voltage regulator has to be installed. Okay, why is the voltage regulator has to be installed is okay. Let me explain again. Okay, from thermal energy, that energy I'll be converting into a battery. Okay, from that battery, I'll be having an output socket outlet. Okay, why do I have the socket outlet? Is for people to use it. It's a usable electric. So mostly, okay, first thing is I'm placing my project in a porch. Okay, why I say it as a porch is my socket outlet will be placed at the porch. Okay, the condenser that this one is, most of the houses nowadays, they have plug point at their porch for outer usage. They don't have to be taking in extensions from inside from their house, which is actually troubling them. So we will provide a socket outlet at the outside house, which will be easier for them. They don't have to, as what I said, that they don't have to trouble themselves. Okay, why I'm saying at porch is because most of the condenser nowadays is being placed at the rooftop front rooftop of the house. So from there, it will be easier for us to just pull the wires and install the plug point. Okay, next is by doing this project, it actually helps our country to achieve green environment. Okay, next will be my objective. First objective is to investigate the potential energy from the air conditioning system using a thermoelectric generator, as what I've said just now. Second is to propose methods for energy harvest from waste energy of air conditioning. Third will be to determine energy harvesting for air conditioner and verify its performance and effectiveness. Okay, here comes the project scope, which I'll be explaining detailedly about the objective. Okay, first is testing the project on a 1.5 horsepower air conditioner and 1 horsepower air conditioner to determine the greatest output producer. So by me testing this one, I'll determine which one to be used for my project. Second is converting the heat energy into a 12-volt silk lead acid battery system by stepping up the voltage, which will be then be transferred to an inverter to be converted to AC current, such as a socket outlet at the port, what I have explained just now. Okay, so by me converting the TEG into, by me transferring the TEG's output into a battery, I need to step up because TEG's output is not as sufficient to charge my 12-volt battery. Okay, for me to charge my 12-volt battery, I need a minimum of 13 volts. So that's why I need to be, that's why the things need to be stepped up. That's what I explained just now. Okay, my third one is setting the effectiveness of TEG module in series or parallel connection for 1.5 horsepower and 1 horsepower air conditioning. Okay, next is in chapter 2, I'll be talking about my TEG. Hold on a moment. Okay, we'll be talking about TEGs. Okay, what is TEG? TEG is the spec of my TEG is SP1848. What is TEG? TEG actually converts temperature differences into usable electricity. Okay. Second one is there's 3 types of TEGs, which is Peltier, Seebeck, and Thomson. Okay. Next is TEG requires heat as an energy. Okay. Why do I say so? Because as everyone knows, it's thermal electric generator. So if both my panel sir and madam look carefully at the schematic diagram of a single thermoelectric here. So TEG actually needs heat input and also cold. So TEG needs, that's why my TEG is being placed at the discharge pipe where I'll take heat, and the cold part I'll explain later. So this is the schematic diagram. The next is advantages of TEG. It's silent in operation, works effectively in high temperature, and the last one is mostly used as a power generator. So that's what I'm doing. So this is my data sheet of TEG, which is SP1848 Peltier. Okay, this will be the performance value, hot side temperature, max temperature, Imax, Vmax, AC resistance. So this is my sizes. That's what I said just now. There's hot side and cold side needed for the TEG to be functioning. So the hot side will be at the back part, cold side will be at the front part. Next is battery. The battery that I'm using is 12-volt silk lead acid battery, which is 7Ah. Okay, what is 7Ah? 7Ah means battery will produce 0.35 ampere per hour for 20 hours. So 20 times 0.35 is equal to 7Ah. So this is my battery, this one. Next will be my inverter. Inverter, what is the function of inverter? Inverter converts DC to AC, and my inverter is 1000 volts. The best part of my inverter is I have plug point together with my inverter, so I don't have to actually come out with a different socket outlet and so on. So my plug one is there. I just have to place it where we need it. Next, this is my compression of literature review table. So I have a total of 15 literature review, which is almost the same to my project, and also there is same to my project. So what is the differentiate between me and them is I'm coming out with a socket outlet where they did not. So that's the advantage of this one. So next will be my block diagram. Okay, first is air conditioner condenser goes to, from air conditioner condenser, what I have explained just now. From the discharge pipe, we'll place the TEG. From the TEG, it goes out to the battery, which being stepped up, and the battery gets charged. From the battery, it will go to the inverter DC to AC, where it converts from DC, because battery output is DC voltage. So from DC, it converts to AC, and it goes to the socket outlet. Next is my flow chart. Okay, for my flow chart, it's from start, it goes to thermoelectric generator, get heat energy from discharge pipe in compressor. I've explained just now. The interaction of heat with the body of TEG module. Next is the terminals for the components are connected in series or parallel. Next will be output is generated as desired. Okay, next decision will be output voltage and current battery are measured. If the battery is in full condition, then hence this one will stop my process. If it's not, then it will continue back to the output is generated as desired, and will continue until my battery is fully charged. Next will be my series connection of TEG. So this is how I have connected it. So the negative terminal of one TEG combined with the positive terminal of the second TEG. So this is how the connection looks like for series, and this is how connection looks like for parallel, where for all the positives will be combined together and all the negatives will be combined together. The next is the exact placement of my TEG SP1848, where it is being placed at the compressor, near to the compressor discharge pipe. Okay, how is it being placed is it will be in a sandwich mode of sandwich mode between copper plates, two copper plates. Okay, the discharge pipe from compressor gives the heat at the one side of the copper plate, and the TEG's back part will be heated up. And for the front part, we have to remain it cool. We can't give it heat together. So that's where another copper plate will be placed, and aluminum heat sink will be placed there to remain it cool. This will be my project costing, which is total of 425 ringgit. Both my panel sir and madam definitely have a question regarding that. Why is it so expensive? Okay, by us doing this, by us spending RM 425 ringgit, we get two benefits. First, the benefit will be for our country, which is our country gets to become a green environment. Second will be the user which is using this one, they don't have to pay electric bill for that specific plug point. Okay, for my chapter 4, preliminary result, so that will be my 1 TEG being tested, which gives an output of 0.6 volt. And this is the placement of my TEG, which is that is what we call the discharge pipe. And here will be my placement of TEG. So this will be the copper plate. Okay, next will be my series connection of 3 TEGs for 1.5 horsepower air conditioner. Okay, as you can see, the output I have recorded after 30 minutes is 0.283 volt for series connection. Whereas for parallel connection, the final output will be just 0.163. So from this, we can say that definitely I'm going to choose series because series gives more output compared to parallel. Okay, next will be for 1 horsepower air conditioner. For 1 horsepower air conditioner, it will only produce 0.183, which is lesser 0.1 compared to 1.5. 1.5 produce 0.283. 1 horsepower gives you 0.183, which is 1.5 gives you more 0.1 volt. Okay, next will be parallel connection. Same goes here, 0.063 for the end product, which is very low, so I'm not going to use. So definitely the last option was, so here comes to the conclusion. So objective and scope has been achieved. 1.0 horsepower air conditioner is being selected as what I explained later, where 1.5 gives you more output, which is actually easy for my battery to be charged in a shorter period of time. So next is selection of TEG is very important. So that I have chosen the Peltier, which is actually the best among this one. So the last one will be heat energy released not being wasted. So heat energy, we have to actually recycle the heat energy, which will be helpful in our future, and also which will be helpful for the users by saving the electricity bill. Okay, that's all from me for both my panels, sir and madam. Thank you very much.